Welcome to Fun with Drilling Engineering. I really like to ride my bike, and for that I need my tires. Unfortunately, they have very limited power. If at all, they can perhaps achieve 200 watts of power. That is about a third of a horsepower. To ride, I still have to somehow get that on the street. My performance can be defined by this formula here. You should remember it from your physics lessons. This formula tells us that with the available power of my legs, I can either drive either with a high speed or with a high torque. Climbing uphill will require more torque, and going downhill will allow driving at high speed. So in order to adjust my power to the changing conditions of the route, I will use my bike's shifting gears. With a small gear at the back of the wheel, I can drive very fast, but only little force is required. For example, if the road is flat or a tailwind is blowing. But most times, like most cyclists know, the wind will come, of course, from the front. Therefore, most of the time, I have to select a bigger gear on my back wheel. Now, on one hand, I have much more force available to fight the front wind, but on the other hand, my speed will be reduced. Hence, I drive much slower. What has this got to do with drilling engineering? Aren't we here for fun with drilling engineering? Well, everything is the same with the downhole drilling motor. A downhole motor has a certain power available, but there are many different drill bits that can be connected to the motor. Some of these bits require high speed, while some require high torque. Of course, downhole motors cannot be switched back and forth between different gears similar to bicycles. But downhole motors can be equipped with rotors of different shapes, as you see here. Here, for example, I have a rotor with many teeth on its outer diameter, just like the large gear of my bicycle. Such a motor like this will develop high torque, but it will run at a slow speed. And for this other motor here, you can see it has less teeth on its outer diameter. It therefore runs with lower power, but higher RPM. In drilling engineering, we even have some motors with just kind of one tooth on the outer diameter, like this model here. These are typical high-speed motors which in turn provide only very little torque. The gear shift like we have on our bicycle is called lobe configuration for our downhole motor. We see here some typical lobe configurations. For example, this here, which I just showed you earlier, is called 5-6 lobe configuration, because the rotor has 5 teeth and the stator has 6 notches. The lobe configuration of a downhole motor tells an expert already at first glance a lot about the characteristics of the motor. So he immediately knows which application or which drill bit is suitable for the motor. And since the lobe configuration of the motor is such an important parameter, it's usually written boldly at the top of every downhole motor technical datasheet. These are many other interesting things about drilling engineering you can learn in our lecture, Fundamentals of Drilling Engineering, here in Freiberg. We'll be happy to welcome you. Look off.